Now for our calculation, when we're going between two curves, we always want to make sure we're subtracting an upper function from a lower function. And so one place where we can run into trouble is if we have a function like this, where we have a parabola coming like here and then a straight line going through here, and we notice that the parabola is crossing a couple times. So in this region here, the parabola is above the linear equation. For this middle region, the linear equation is above the parabola, and then for this one here, we're going back to the parabola above the linear equation there. And so for these ones here, if we get those crossing curves, what we're going to need to do is we're going to need to find where these intersection points are, and then we're going to need to break it up into regions. So we'll solve for this region, where the parabola is above the linear equation. We'll solve for this region separately, where the linear equation is above the parabola, and then this region here where the parabola is above the linear equation. Otherwise, what's going to happen if you just say pick the parabola as the upper function, this will solve for a positive, this will solve for a positive, but you'll end up subtracting this area instead of adding it, and so you'll get a lower value than what you actually want. So what we're going to do then, as we said, we'll break the domain up into regions so that each region, or in each region, one function is always above the other, and then we can add those regions together. So for this one, we're not going to do the whole region here. Our boundary conditions is going to be the y-axis. The y-axis and x equals 5. So we'll take this as one of our boundary conditions, and then our y-axis over here will be our second boundary condition. So that means we're going to have to break it up into the two regions. Now we can clearly see that this one shows up at 3. The other way you can solve for these, of course, is just make the two functions equal to each other, and that will give you then the intersection points. So if we just do that for a moment, take 2x squared plus 10 equals 4x plus 16. I'll move everything to one side. Gives me 2x squared minus 4x, and then that'll give me negative 6 equals 0. I can divide both sides by 2. Gives me x squared minus 2x minus 3 equals 0. And then that one's easily factorable to x plus 1, x minus 3, still equal to 0. And so we see that x equals negative 1, which is that one over here, and positive 3, which is this one over here. Now this one's outside our region there that we're solving for there, and so we just need to worry about this one. So what we're going to do is we're going to break this up into those two regions. So the first region we'll look at is 0 to 3. And so for that region, 0 to 3, what we notice is that my linear function, which we'll take as g of x, is above my parabola, which is my f of x. And so for this region here, we can say that g of x is greater than or equal to f of x. And so when I set up this one, I'll take g of x minus f of x, and that should give me then the region that I'm looking for. So I'll call this function h of x, which is then just g of x minus f of x. And so we can put our values in for those. So h of x is going to be 4x plus 16. And I can subtract again. Don't forget the bracket when you're subtracting here. There's two terms, so if you forget to put in the bracket, it's easy to miss the negative sign on the second term there. So I get 2x squared plus 10. And so when I simplify this for my h of x, I'm going to get negative 2x squared plus 4x, and then plus 6 overall. So I can take the antiderivative of this one here. And again, we are, as before, we're just using the polynomial rule for this. So I'm going to get negative 2/3 x cubed. This will be 4x squared, but over 2, so I'll end up with just 2x squared there, and then plus 6x. Now I do also, of course, have the plus c there, but it's going to cancel out when I take the when I subtract the 2 from my area function, so I'm actually just going to leave that out. Now for the next region there, we'll come back to this in a moment, my parabola is above my linear function, so I have f of x being greater than g of x. And so for this one here, from the regions 3 to 5, my f of x now, which is the parabola, is going to be greater than or equal to my g of x. And so I'll come up with a new function p of x, which will then just be f of x minus g of x. And we can solve for that in the same way as we did before. But now I'll have 2x squared plus 10, and I'll be subtracting my linear function, 4x plus 16. And so we can solve for that. And I'll get 2x squared, now minus 4x, and then minus 6. And you'll see that it's basically the same, just with all the signs flipped around. And so my antiderivative is going to go the same way, just with different signs. So I'm going to get the 2/3 x cubed minus 4x squared divided by 2. So that'll just go to 2x squared, and then minus 6x. We have the plus c as well, but again, we're not going to be bothering with that. So then I have to solve for each of those two areas separately. So if I look at the area on that domain 0 to 3, including the endpoints there, my area is going to be h of 3 minus h of 0. So my area here, h of 3, I can just put 3 into this equation. So I'll put a bracket around there. 2/3 times 3 cubed. Plus, now this went, of course, just to 2x squared. So I'll have 2 times 3 squared, and then plus 6 times 3. Now, notice we have an x in each one of those terms. So when I look for h of 0, that whole thing is going to go to 0. So I'm not going to expand that whole thing out, but that term will go to 0 for h of 0. So my area, when I solve for this one here, is just going to actually end up being 18. So that's the first one there. Then we can go to the p of x, and we can look at then the area over the domain 3 to 5. And that's going to come from that function p of x, because in that region my f of x was higher. So now I'm looking for an area p of 5 minus p of 3. And so we can put our values in for those. And so we're now using this equation here. So I'm going to have for my first one, I'll have 2/3 times 5 cubed minus 2 times 5 squared minus 6 times 5. And then I'll subtract from that 2/3 times 3 cubed minus 2 times 3 squared, and then minus 6 times 3. Okay, and that one up there. So this area here, when I solve that, will give me 10/3 for that first one, and then subtracting a negative 18 for the second one. And so that area will end up being 64/3. So my total area, which is going to be this area here plus this area here, will just be the sum of those two. So I'll get 64/3 plus 18, and if I add those two together, 118/3. And that will be the area then from 0 to 5 between those two areas.